Hi, my name is John. Welcome to another Sunday night nightcap. The first thing I'd like to do is say a massive thanks for all the well wishers that have been coming in towards my dad. My dad's still in hospital. It's going to be quite a while, I think, before they get him up on his feet properly, but he certainly is improving. So once again, thanks for that. Tonight's nightcap, I've got the normal mixture of machining, welding, plasma cutting. I do some brazing on a big cast iron gearbox casing. I'll show quite a bit of that. First thing I want to do is the draw for the little Clark 0 to 1 inch micrometer. Put the hand in the bucket. There's a steady trickle of names coming in there. It averages between sort of 40 and 100 a week. Right, let's have a look, see what we've got. The name is John Cameron. As usual, all you need to do, send me an email with an address and I'll get that posted off to you straight away. I'm going to do another draw. This time it's for another Clark micrometer. This is the Clark 2 inch micrometer. These were actually given to me by a friend to be given away. I mean, I've got a 2 inch micrometer I use. I don't need another one. It's absolutely brand spanking new, nearly out of the box. I'll get a close-up shot of that a little bit later on. As always, if you want a chance at winning that micrometer, all you have to do is send me an email. That's my email up there, containing your full name, like John Mills, not just John. Your name goes into the bucket. If it's drawn out, I will post it off to you anywhere in the world, completely free of charge. Like I said, that micrometer is absolutely brand new. I've got quite an interesting job to do here. This is a big heavy duty Mercedes gearbox, and the lads actually grafted on a bell housing that'll take a Volvo turbo petrol engine. Modified the first motion shaft, actually made that little bush that he's welded into there, spigot shaft bush. That's the clutch master cylinder there, and the clutch fork goes across there like that in pivots on a point in here. Now the pivot point's at the wrong height. That's the original pivot point, like a plastic pin that plugs in. They wanted me to make a steel one which was longer and adjustable. The problem with the steel one is if you run steel into there, it'll without a doubt wear a hole straight through it. That's why you have a plastic affair like that, and it's also got a spring clip which goes into that groove which holds the clutch fork in. Now what I intend doing is drill that out 14mm, put a 16mm top through it, and I can use a 16mm bolt, machine the head down, drill it out and put that plastic sleeve into there. Then that'll screw into there and be adjustable and have a thin check nut on. It needs to come out roughly ½ an inch to about there, so there's enough room to get a thin check nut in there and have it adjustable so you can set his clutch clearance up spot on. So the first thing to do is to drill that out 14mm. Obviously I cannot mount it anywhere, I'm going to have to drill it freehand using the eyeball method, which should work out not too bad. These pieces are determined to get lost. I'll have one of them days in here today. But right, so the first thing is we'll get a 14mm drill into there. Well, we're going to fix the bastard now, I suppose. Right, and that's a 16mm top that needs to go into there. Right, that top looks good. Started nice and straight. It's going to have to be because it's in now. A bit of WD-40. There were plenty of threads in there now. Try the 16mm one, John, will fit better. Right, so that's a nice fit in there. Need to machine most of the head off now, and then drill it so that slots down into there. Then checking it on there, and that's basically the job done. Right, I've changed it over for the collar chuck, just it means it won't damage the threads on the bolt we're using. This bolt's actually stainless, nice high quality bolt. It doesn't have to be stainless, I just happen to have a stainless steel bolt, that's all. I'm going to drill this all the way through, then it means if the plastic bush needs changing, you can just punch it out from the other side. But if the hole's blind, obviously I'm probably trying to get it out. As long as the swarf's coming off clear like that, you can keep on going, as long as it's clear on its own swarf. Once it starts to pack up, then you're going to, like that, that's time to stop, then we drill the outer hole bigger, just to get some clearance on it. I think we're just about through now actually. I'm going to shorten the bolt down anyway. Right, that's it through. I've got a 9.5mm drill, that should give us a nice fit, like a tap-in fit on that bush. Horrible swarf coming off that stuff, to really cut your ribbons, it's nasty, hot as well. Right, so that's going to be a nice fit in there, a little bit of Loctite on that. Not that it can go anywhere because the clutch fork's actually pressing against it. Just about going there. I like it. Right, so hopefully that will screw into there. I can make a little thin check nut to go onto it. And this is, of course, it's easily adjustable. And his clutch fork goes on like that. Look at that, it wants to come out a little bit more so it's level, but it is fully adjustable now, and that's not going to give any problems. It's not going to wear a hole in the clutch fork. It's a strong, proper job. What I also can do is I can weld a little Allen bolt into there, because that actually protrudes through the back of the bell housing, and you'll be able to adjust it from the outside with an Allen key. So I think that's going to work out quite nice. I'm quite pleased with that. I've got a job here that I don't really want to do, but it's for a friend of mine, so I said I would have a go at it for him. It's a gearbox casing of a David Brown tractor. It's got a crack in it which goes all the way across there, all the way across to there. Normally I would drill the crack right out, but he doesn't want to lose the lettering because he actually shows the tractor. I'll turn it over and show you what's happening the other side, which makes it even worse. It's actually being MIG welded with steel over the top of the crack, and the MIG weld's got a crack running all the way through it. There's a bit of stud missing there. Like I say, normally this should be V'd out and welded. I'm not going to weld it. I'm going to grind this weld flat, and I'm just going to braze it using oxypropane and ordinary brass and flux. I don't really want to go with any of this with a TIG welder because I know what will happen. It'll start to crack. But I think a big flame on the oxypropane should get enough heat in there to be able to braze it. So first thing is to try and you see the cracks in the weld. I'll get a closer shot of it. I hope you can see that there, the weld's cracked. Right, I've done a bit of damage to it. I can see the original crack running down there. So I'm just going to try and put a nice fillet of brass over the top of all this mess and see if it will seal it up. Bastard, flux pins on fire there. It's always handy when your son's built like a shithouse.